Hi everyone, welcome to a Konveyor meetup. Today we have Anup from IBM Research who will be presenting TCA or Tackle Container Advisor to us. Super excited for this as it is one of the community tools. Before I hand it over to him though, I do want to go over just some housekeeping items. So first of all, if you have questions, please put them in the Q&A. If Anup comes across a good stopping point, I'll ask him the question, but if I see that he may need a little bit more time, I'll probably just wait until the end to ask him. Second, I will send out the slides in accordance to this, probably 1 to 2 days after this meetup ends. And as for context as to like why we're so excited about TCA is because like it's part of Tackle. So within this, when you look at this slide right here, you'll see all the different tools that are within the community and the use cases that they solve for. Now, like I said, TCA is part of Tackle, and I will actually allow Anup to go into more detail. But I just wanted to show you this just so you get to understand the big picture or where this fits into all the other tools that we already have and within Tackle itself. So Anup, with that, I'll hand it over to you.
Thanks, John. So let me share my screen quickly. Okay. Hello, everyone. Good morning, good evening. I'm Anup Kalia. I'm a researcher at IBM Research, and this work, Tackle Container Advisor, is in joint collaboration with people from IBM Research Hybrid Cloud, IBM GBS, and IBM Research AI. So my whole agenda of this call today is I will take you through 3 parts of TCA. One is the purpose of TCA, how these tools look like, what are the things there in the tool, and what you can do out of it. And the second part would be I will do a more deep dive of TCA into understanding the technical aspects of the TCA. And the third part will be the demo. So let's go to the purpose of TCA. So why TCA? So in general, like client before even starting to begin with the modernization journey, they could really want to understand what aspects of the application can be containerized or cannot be containerized. In general, like what aspects could be modernized or cannot be modernized so as they could migrate to cloud. And to do that, client could have a very high level description of their applications, not even begin with the source code in terms of natural language text, or even they can provide their CMDB dump data or any other data that we can analyze. And typically, such application portfolio could have thousands or even 10,000s of applications and their components. So one such example, a few such examples here are, for example, this is one of the application which has the following description that you get from clients, like this application, as you can see, is a combination of both mainframe and other related aspects like Java, the COBOL, Java, mainframe, DB2, Oracle, and so on. Then there could be other description, for example, MQ client, write fax, SQL Server, Windows, and so on. So what people have been doing as far as now is that what they do is like given such description, SMEs or subject matter expert would actually go through each and every application, manually verify each and every entity, and then somehow determine the container candidates and provide an overall modernization advisory. So the very purpose was to actually remove this manual step so as to reduce the time in doing this or completing this, and also increase the accuracy. So TCA does that in a kind of automated way where it maps this application to container candidates in different catalog. As of now, we support catalog like Docker Hub and OpenShift. So this is an example, right? I mean, we take the same application description as I showed you in the previous slide, and we have this following recommendation based on this application in Docker Hub as well as OpenShift. As you can see here, some experts of the based on some experts in this application, we could map it to Docker Hub images like DB2 and Oracle database, and similarly in the OpenShift as DB2 and Oracle database images. But apart from that, we also provide some high-level other insight. For example, we could actually detect something that is unknown. So there is one technology element like VSAM, which is not present in our knowledge base, and we can say that, hey, this is something unknown that we don't or we are unaware of. Then there are certain elements that do not add to the containerization aspect, like very general level entities like SQL. Sometimes people write XML, HTML, and so on. Some other aspects that do not have any candidate container, although we can identify them, but they cannot be mapped to any candidate container like Unix or mainframe. So overall, TCA not only generates such container image recommendation, but kind of provide an overall picture of what things could be or could not be mapped to the container. And hence, it provides a very high-level overview toward a modernization advisory for clients. So there are following components in TCA. So there are 4 major components. So this is the most important component called TCA backend API. In general, within this backend API, you can see there are 3 subcomponents like a knowledge base, which is kept in a JSON files. There is an entity standardization model, which is more like an NLP/ML model. And then we have one expert that uses this model to generate the assessment for the client application. And then we have the one downstream task called containerization planning that generates container image recommendation. So what we have done is that we have created in a modular way so that you can add more downstream tasks to it based on this high level information that we extract from container application description. And we will talk to the details. Coming to the other component, we have the original knowledge base is in terms of a .sql file, which is more like a database. This is in terms of SQLite 3, so that is easy for people to kind of port it and use it. We have a KG util module that generates this knowledge base in terms of JSON files. So all of them are initially loaded when this API gets built. And then we generate or create this entity standardization model from a specific data called mentions. I will talk about that as well in the later slides. How to run this TCA backend API. So what you do is that you git clone the repository and then you CD into that folder and run the shell script run.sh. A prior prerequisite you might need is a Docker Hub. If you don't want to run this shell script, you can also run the Docker command like Docker compose, and you can build that API and you can get started using it. So in that list of APIs, we have two API as of now. One is containerization assessment API. It takes the application input in the following format. Sometimes client could have information in the separate columns, like like for example, OS in the OS specific columns or other information in other columns like middleware database. And sometimes the information could be noisy because sometimes people could keep programming language under database, and that's okay. We don't need to worry because TCA takes care of that. In general, you can provide all these inputs in one line as well, like comma separated value as a technology summary. So what it does in the first part is that it normalizes or standardizes all the input. Like for example, C# into C#, IIS into IIS, SQL Server into MS SQL Server. If you have a version, it also splits the version and shows you accordingly. Apart from that, we generate other information. For example, sometimes there could be ambiguity, primarily because of how a model performs or even lack of data in our knowledge base. So it might give you values that are ambiguous in terms of medium or low confidence value. Some of the values are general technology, as I mentioned about SQL, HTML, XML, and so on. And sometimes they are completely unknown because it actually goes beyond the low threshold values, so that we detect it as unknown, and that is the entity that is not there in our knowledge base. Now, once you get those assessment report, you can actually feed that information into another API called containerization planning. So you can feed this information as you can see here, C#, IIS, SQL Server, I feed them. And based on that, it generates the Docker container recommendation. For example, from this information, I could generate 2 Docker container recommendation, one Microsoft SQL Server, which is a verified image along with the URL. Another is window IIS. Somehow C# was not present in those images, so we recommend additional installation is required, and we generate a confidence value as a 0.93. Since we could containerize everything, we recommend containerization. But there will be certain instances where we may not containerize the values simply because they were not detected correctly, or they were unknown, or they were general technologies. So we might recommend partially containerize. And in some cases, there would be a possibility where you do not map to any candidate container, then we generate no recommendations. So based on overall, like when you feed thousands of applications, you can generate an overall summary of such recommendations and provide to the clients. So this is now that's next part is like when you modify the knowledge base, then what are the steps you need to follow? So this is a entity relationship diagram. I will talk through more details about the tables and the values they carry. For now, I can give you a very high level overview of the tables. Like we do have tables like entity types, entities, entity compact relations, entity mentions, and Docker images and OpenShift images, and so on. So what you do is like, I mean, in general, this is a SQLite 3 database. So I just upload this database as a .db file to dbeaver, which is open source tool again, so that you can view and you can modify them, or you can actually write SQL queries to feed new information into the knowledge base so that you can keep on expanding that. Once you do that, it will generate, you can generate a new .sql file and update the existing SQL file, and then go to the main repository again, like from where we started, and then run this shell script called setup.sh, so that it generates everything, again, like all the JSON files required and all the a new model, and it will copy it everything into the backend API so that you can read on the backend API and to visualize or see how your new entity, is happening, or how you can make use of the new entity that you added to the database. So, and again, after that, you can also append a whole new KG. For example, you want to use our KG, you might have your own KG. You can also do that. You can replace the existing SQL file with a new SQL file, but you might have to do certain configuration in specific folder. We do have an entity standardization folder where you might have to change some aspects of the configuration related to DB path, KG util folder as well. And then in the setup script, you need to add these two or replace these two lines with a new DB SQL and the DB file, and then rerun the setup.sh so that it generates everything new for your data and it make it work. I will show you the demo as well in this so that I can give you the flow that how you want to do that. Any questions so far, or else I can go to the next one, which is really I want to do a technical deep dive into TCA.
Yeah, Anup, we actually have one question here. So,
Okay.
are the use cases here different from the IBM Transformation Advisor?
Yes, a bit. In general, like IBM Transformation Advisor take the source code, like the application code and the server files into consideration to generate a recommendation. Here, we don't need any of that thing. Here, a very high level description is sufficient. And as such, Transformation Advisor can take only one application into consideration at a time. But here we can do thousands of applications at a time. So that gives you a high scalability on this aspect.
Okay, awesome. That was the only question for now.
All right, thank you. So let's move to the challenges. So what is the task that we're really trying to do here? We are trying to give an application description. We are trying to create a recommender to generate candidate container. So this is the overall task. But remember, like such overall, there could be so many overall tasks like this, and there are additional challenges with respect to application input that we opt in from client. For example, input can be really noisy because somehow the way they speak or interact with among themselves around these technologies, they will actually mention that as well in their input. For example, you would see that several times people would call out Red Hat Linux as RHEL, then ODM, Westphere Application Service as WAS, then AS400. So in general, they could have abbreviations, numbers, punctuations, and symbols. Could have multiple variants. People could call Oracle as just simply as Oracle, Oracle 10G, Oracle DB, database, and whatnot. They could have redundant information that we need to remove. They could have unknown. This is the most important part that we are kind of trying to handle. And then they lack surrounding context. For a lot of machine learning and an NLP algorithm, if you see, they work on unstructured text, which has like surrounded entities or values to kind of give more evidence of what this specific entity looks like. But here we don't have that kind of luxury. We get all these comma separated values, and somehow we have to standardize them and kind of use them for the container mapping. So for this one particular task, you might need like a whole enormous data to build a model around that, right? Imagine there could be so many other tasks like 6-hour disposition to begin with, or create some pricing model around that. So then for every step, you don't have to really build a model. So that's what we propose as semantic aspect by creating a knowledge graph around it. So if you have a knowledge graph as a central core core aspect to this, then you can use those knowledge graph to normalize these entities, this noisy input, and convert them into a representation that could be used by other downstream tasks. And how we will do that, I'll explain in the next slide. So first of all, what is our knowledge base, TCA? As I mentioned, I will explain the details here. For example, we have entity type table. It could pick up different entity types, very high level types like operating system, programming languages, application, which could have database, softwares, and middleware, then application server, library, and runtime. Actually, we have more. I will give you the statistics of how many things we have for now. And then we have entities. For example, we have this IIS entities that has a mapping with the application server. We also, in addition, we create a mapping with the Wikidata. So that's one of the large database because in general, Wikidata has a lot more information. So if we have that QID mapped, then we can extract many other information like version, release dates, your other experts like mentions and whatnot. So, in general, and the idea is to keep on propagating to other large knowledge graphs so that we can have that aspect of it. Then coming to entity mention. So to do the entity standardization, we need few labels across each entity. For example, IIS, we have labels like IIS. I mean, how it is being called in natural way, IIS Web Server, Internet Information Services. And then from MS SQL Server, we have things like Microsoft SQL Server, MS SQL, MS Space SQL, SQL Server. So there are so many ways people call it out. So we want to have some kind of data so that we can build a model around that to kind of filter out or map the noisy input to the exact entities in our knowledge base so that we can do the downstream task. After that, we do have entity relations. These are extremely useful to actually recommend Docker images, because if you see Docker images or container images are really a construct of not only individual entities but composed entities. For example, Tomcat image could be composed of OS like Linux, the product like Apache Tomcat, and the programming language like Java. So in general, like what we really need to understand that if all this have a compatible relation. For example, if Tomcat can be installed on Linux or not. And here we have an example like IIS can be installed on Windows. MS SQL can be installed on both Linux, Windows, and as well as Unix. So we capture that aspect so that we can reason out not only the compatible relations, but also we can infer the missing information. For example, if somebody did not give Windows as OS as input, we can still infer the missing information that, hey, IIS is actually compatible with Windows, so this is a probable OS that people should have given actually. So that really helps. Then after that, we do have the list of images, like the Docker images. We have Windows Server Core, Red Hat, and a bigger list of the things. Similarly, we have OpenShift images as well, like SQL Server, Red Hat Container, IBM SQL Liberty, and so on. And then apart from, we have some of the base OS images, like Docker base OS images, which are like Ubuntu, CentOS, Red Hat Linux, and Windows Server Core. And OpenShift base OS images, we have like things like Red Hat Enterprise Linux. These are all required actually to map client application to the candidate container. So we have the following stats regarding the data we have. So we have total 12 entity types, and the stats will be updated actually in the actual data in our open source tool today we will release on this. Previously, we had some few of the entities, but now this month we are releasing with a larger entity portfolio. So we have 610 entities all total. As you can see the distribution of such entities. For example, application which has database, middleware, software that take the highest number, around 268, followed by programming languages, 88. Technologies are very general technology elements, like for example, HTML, XML, SQL, and so on. And then OS, we have 51, library, we have 43, application server, 34, and so on. In terms of how many things we could actually map, we could map around 447 out of 610 to the Wikidata, simply because a lot of tools are not registered to the Wikidata. As such, we cannot get the relevant QIDs. So the idea would be like either you can manually populate those information Wikidata so that we can use them for automation. If not, then most of them would be ignored, or we can manually add the information related to the entities in our knowledge base. So we do have entity mentions around 483, which is, as I mentioned, there are few labels across each and every entity. As such, you can see a large label. Entity relations, they're primarily, I mean, we did capture a lot of other relations like runtime on the particular relation between programming language and runtime, or application server and runtime, and so on. But most of the relation, as you can see, that apps or app server would have the relation with like specific OSs, or programming language with specific OS. So yeah, so the that would be the major relations that you will find in our tables. Apart from that, we have as of now 164 Docker images, which is verified or could be official images. Similarly, we do have OpenShift images like 54. And why, you might assume, like we have millions of images in Docker image, and why such number is low? In general, this tool actually evolved from an IBM internal tool, and for those like the initial data actually came from around the client, and these covers around the very like high distribution or very frequent kind of data. As such, the numbers are low, but our aim in the next iteration is actually mine entire Docker images and OpenShift image list to kind of augment to this knowledge base. So now coming to the core approach of entity standardization and how we do it. So in general, like we receive obtain information in terms of raw input application input, like for example, you can see here C#, WinForms, IIS, and SQL Server. So this is how we get the input. We do some pre-processing. For example, we might remove certain slashes or represent in a way that could be understood by our AI algorithms. And then we split sometimes the versions to because we think the version is another problem that we need to deal with. As of now, we are not dealing with. So we can obtain the version separately, and we can obtain the mentions along with the versions and without the versions, so that we can feed this information into our entity standardization model. However, entity standardization model is composed based created using mentions and entities. I will explain you the model in the next slide, how we create that. So once we obtain the so based on the entity standardization model, we obtain a name entity. For example, you can see that for C# WinForms, we obtain C#, IIS, we obtain IIS, it remove the redundant information, and for SQL Server, we obtain MS SQL Server. Okay, so these are the three inputs we obtain. Now, how we do the generate the recommendation. So there are actually few steps. So first step is actually reasoner. First step, we really want to understand the missing information. As you can see, there is no OS information. So from the compatible relations, we deduce the OS information, and also we deduce candidate components. So you have to understand that in general, like how the application is containerized. An application is containerized, it could have this own core aspect like the source code and other external dependency that it needs, like database or middlewares and so on, so that you need to containerize each and every dependencies, and then you can actually containerize the whole application. So for that same reason, what we do is, like, given the application input, we detect all these application components. For example, here we detect the component from this input as one of the components Windows, IIS, and C#. For MS SQL Server, we detect like Linux. Why with Linux? Because MS SQL Server is actually can be installed on three things, as you saw in the compatible relations, right? Linux, Unix and Windows. So Linux and Windows have the container images, Unix doesn't, and we kind of prioritize Linux over Windows. As such, you can see the application component that is being generated as the following. So these are the two, you can see this is the two complex or composed entities, components based on composed entities. Now we map based on a matching rule. I'll explain the matching rule, how we do that. But the requirement is the following, that we convert or represent all these container images in terms of these entities as well, correct? Because it's very difficult to map them directly. So we kind of manually, provide those entities so that we can use these components along with these entities based on a matching rule, generate the candidate container recommendation, and also we generate the confidence score. As you can see, the container image recommendation IIS container image and MS SQL Server image. So this is the core aspect of entity standardization model. It's a very simple model based on TF IDF. The TF is IDF is abbreviated as term frequency and inverse document frequency. So what we do is that, and the primary algorithm is related to document search. So what you can do, like for example, let's say we have these 7 documents, and each document represents the entities and the mentions mapping. So what we do is first is convert them into this particular vector representation. As you can see, every document uh, is converted into some values, and the values are based on the features present or may not be present in each document, and you get that whole matrix. So now, given a query, like if I'm searching for MS SQL, we transform that into this particular vector representation so that you can get the appropriate values. And now we cross-reference this vector with all these vectors using the cosine similarity to get the exact matching. For example, MS SQL get matched with a D6, which is really MS SQL Server. So now you have this information and you can extract the standardized entity. And based on standardized entity, you can extract the app because we have all those mapping covered. For more details, we have a paper published this year in IEEE Cloud. So you can also know the baseline benchmarking and so on that we have published in the paper. So now coming to the reasoner that I explained, right? So given this input information, first we deduce all the missing information. For example, IS MS SQL Server deduce that Windows could be a possible OS, for MS SQL Linux could be possible OS, and then based on some more reasoning, we assign IS to Windows, MS SQL to Linux. Similarly, for this particular application, we have things like DB2, Oracle, COBOL, Java, JavaScript, they are Windows as well as on Linux. But since we prioritize Linux over Windows, we generate these two components, one DB2, another Oracle. So imagine so we do take a lot of priority on application and application server first. We want to construct components around that. And then we would add the programming languages to each of this component because we really don't know what goes along what. But imagine like these application servers are not present, only programming languages, then we might want to create the component just using the programming languages. For example, if you have Tomcat and Java, then we would recommend Tomcat container. But if you have only Java, then we can recommend OpenJDK container. So that's how we do the reasoning to determine the candidate containers. And how we do that, we have a scoring point for each. We give a high priority to OS first because the first and foremost thing that you really want to match is the OS, right? Followed by apps and application server, then followed by runtime and the programming languages. So based on the given input, we would compute the score across all the images and figure out the highest possible confidence score and figure out like what are the things that needs to be installed. For example, on Windows IS, we figure out C#. But imagine there's so many actually Windows based images, right? Where you need to install both so that you can make it compliant. Similarly, for other things like Linux DB2, you could again mine through all the images and you can compute the confidence score and the additional installation that is required to make it compliant with that. So with that, any questions or else I can go to the demo session.
Yeah, Anup, I have one question. So I think you touched on this, but it's a little bit more specific to the input. So the question is, does this require some sort of extract or import from a CMDB, etc., in order to do them?
Yeah, so you can, so in general, like you can give an input from, maybe I should go into, yeah, you can give a CMDB input. So what happens is that, I mean, as of now, we don't have a curator that would actually curate through CMDB data and can provide this data information. So if you have a curator, or or you can write a curator that could actually convert the input representation to this format, then we can definitely go ahead and generate all the recommendation. But if it's not, then you can reach out to us. We can write that curators for on behalf of you and can generate this template so that we can get the recommendation for you. But in general, I would encourage, like, since this is an open source community tool, we can talk together, even create a curation tool, right, together to kind of curate a lot of CMDB data for the same purpose. So yeah, definitely different options we could have.
Okay. Well, is that kind of what you've seen so far whenever other people
Yes,
try to use this tool? Or because the other option that they listed out was, or maybe it's just a reformatted output on the spreadsheet that's maintained by the company or the line of business for their applications.
Correct. That is another way. And also remember that that is another way for sure. Also remember that John mentioned about the Tackle component, right? So that comes along with other Red Hat OpenShift tools like Pathfinder and application inventory. So you can also go use those tools to register your applications. And in our future plan is actually integrate ACA or TCA with those tools, so that once the application is fed into those tools, we can take those information and we could analyze. So there are multiple options or path clients could follow.
Okay. Okay, that makes sense. And then I have another question, which is how to calculate confidence target.
Oh yeah, so that is related to here. Yeah. So what we have is like list of all the images, right? And we do have a matching score. So given this component, which is Windows ISC, we start with the OS matching. So for Windows, we give a, like, if it is Windows is present, we give a 40 score because OS is present, followed by if an app is present, we give a 20 score, 40, 20. And then what we do is like we compute an expected score out of it, which is 70, as you can see here. And then we see like how much of those information is actually present in container images. So for example, in Windows IS, we could have like 40/20, which is 60, and then the total is divided, if you can see 60 by 70, score opt-in by score expected. So that gives you like 86% of confidence. So that is a very simple algorithm that we use.
Okay, awesome. And those are all the questions for now, Anup. Thank you.
All right, so let's go to the demo session. Okay, so maybe I should exit and okay. So this is the Tackle container. You can git clone, and we will have, as I mentioned, we do have a backend API component and other component like standardizer, KG utils, and there are some scripts, right? So the first script you can do by default is that I can run this clean.sh that sorry, that cleans everything, and then you can run setup.sh. What it does is that it generates, given your database or SQL file, it generates all the related JSON files. It checks whether all those requirements are satisfied for the backend API, and also it generates the model, our entity standardizer model, so that it can copy to the backend API, and then we can get started with the running that tool. And I think since the setup is script is very simple and feel free to modify. So now you can see everything is set up. So we can just run the shell scripts. That will actually run the backend API container. And also I mentioned that you don't have to go through setup initially. Just run this command, run.sh. If you have a Docker container already installed, it will install the whole tool, because we made sure the model and the JSON files are available on GitHub. Because what we observed by some internal testing is that people kind of sometimes, based on their shells, they kind of face some challenges. So we made sure that at least people get started with the backend API, and then they can figure out like if they make any modifications to the database, then how they would run the setup script to actually make it work through. So now once it's almost done. So yeah, cool. So that is done. So let me refresh this. So this is our Tackle Container Advisor. It has 3 APIs. So this is the first part is containerization assessment. So let me give you application. Like for example, you can give individual components, or you can write everything together. For example, here I can write Tomcat db2, and when I generate this information, what it does is that it kind of standardizes these entities. For example, Java to Java, Tomcat to Apache Tomcat, and db to db2. And then you can write a code, or I'm just, for the demonstration purpose, I'm just copying it here. I can copy this assessment part, which is given as input, into the planning part, so that I can generate the candidate container recommendations. So we have Java Tomcat db2, and what it does is that it will give you 2 images, and the confidence score is 1, simply because everything is installed. But going back to our original example that I showed, C#, IIS, IIS and SQL Server. So it generates, again, the mapping, entity standardization mapping. It generates everything in order. So you can map and you can execute them to generate the container mapping. So now you can see here that since C# was not available in these images, what happened is like we get a confidence score of 0.92, and the additional thing is required is you need to install this. But still, overall, it gives a containerized because both the applications has the available container images. So let's go something more kind of exception kind of thing. For example, we talked about a lot about unknowns and general entities. So let's say I give DB2, Oracle, and SQL, vSAM. Okay, let's try out this one. So now what happens is that DB2 and Oracle get mapped, but there are things like general technologies detected, like SQL, and unknown technologies detected, like vSAM. So we copy this again. So as you can see here, DB2 and Oracle, they got installed, but I get the recommendation like partially containerized, primarily because there are some aspects of that either was not detected or was general technology given. So which our algorithm suggests it could not containerize everything or could not put into every other bucket. It gives a recommendation like partially containerized. But let's say we have things like, let's say mainframe and nothing else, right? So, so it's a general technology detected. That's one thing for sure. And when I take this thing, sorry, my bad, copy. So as you can see, it really generates an empty containerization because simply there is no candidate container mapping. So based on the technology, you can have like a lot of messages and output and information that you can summarize, and you can show it to the client like how the application portfolio looks like, and you can, as I mentioned, you can build a lot more on top of this assessment output and the containerization output, and you can also build your own task and can add to our community thing. So that's almost conclude my demo. So I'll be open for questions.
Thank you, Anup. So right now, I actually don't see any more questions. Yeah, I think we answered most of them throughout the session.
Awesome.
Yeah. So thank you so much. Is there any plans in terms? I think you said you guys were working on a tutorial for this tool,
Yeah.
right? Do you have any timelines on when that will be out?
Yeah. Hopefully, I mean, in the coming 2 weeks, we'll be releasing that. We have almost the draft, but I think we need to go through and I guess the first idea was to give an overview to the audience and then release it so that it gives a better picture of how our tool runs and what kind of things it support and what kind of limitation as well, right? So that we can, and the future avenues, what we need to go for.
Agreed. And is there anything that you guys have in store in terms of like either roadmap for the
Uh,
TCA?
yeah, absolutely. We do have a lot. So definitely a lot of downstream tasks that we want to handle. Like one of the downstream tasks that people in modernization journey do is 6R disposition so that we can add that quickly on, and we need to analyze what kind of data it needs so that we can feed that and can create some rules to do that. Then unknown is one of the bigger challenge, right? I mean, how to handle unknown and also do a knowledge augmentation. So first, for the knowledge augmentation, we are mining through the Docker Hub images and OpenShift images so that we can add more and more entities that could have a target container candidates. And for the unknown thing that we do not have, we are kind of playing with more AI algorithm with our IBM Research AI team to kind of to kind of mine through the universal knowledge like Wikidata or DBpedia to understand those unknowns and add that to our knowledge base. Correct.
Okay,
So a lot of
awesome.
focus on knowledge augmentation and adding downstream tasks.
Yeah. And one question I've gotten throughout the session is, so the documentation available for TCA, is that on the GitHub page for the
Uh,
TCA, or
so
where is that?
Okay, so the documentation that I showed or everything is on the TCA page, like how to run those tools and everything's there. And I can answer the other question that James is asking on Kubernetes and operator. So one of our colleague Mihir is actually working on that. He is almost done. We are planning to kind of experiment on that and kind of add that to our tool as well, so that people can run that on Kubernetes or any other environment. Yeah, thanks for asking that question, James. And that's also kind of part of our roadmap as well. And we
Awesome.
are in interaction. Oh, one more thing I completely forgot, which I mentioned in our talk, that we are interacting with Phil and Marco on integrating this tool with application inventory Pathfinder. That's one of our key intentions, so that we could consume applications from different sources. That is our idea, and reach our knowledge base.
Yeah, that's super exciting. That's eager to see when that comes about. Well, everyone, so that's it for today's meetup. Anup, thank you so much. And to everyone else, I will send out, hold on, I think something just came out. The question just came in, Anup.
Is there any tool? Okay. That's for now, I think we don't have like algorithm around the application affinity. Um, so that definitely that's another downstream task we are. But application affinity again needs some additional information, like your relation of application with the infrastructure. For example, one kind of input that could give you that, okay, these two applications are related, or some common elements, right? So that what kind of data needed and how we can do that, definitely that could be discussed as well. So feel free to reach out to us, and if you think you can add a module, that would be great as well. Correct. Meanwhile, I just want to mention that we are also planning to integrate TCA to wind up for more data and possible. So there are many plans of integration with the existing tools, adding more downstream tasks, as you guys are suggesting. All are very good suggestions. And that's the idea. Like as a researcher, we would build a very general meta model kind of aspect, so that all other downstream tasks could be built on top of this meta model. So that is the idea of TCA.
Okay, Anup. And I just put a link to the Slack channel. So later on, once this meetup ends, if you still have questions, feel free to pop a question in there, and Anup is in there as well, so he can handle them. All right, everyone. Well,
Yeah.
thank you so much, and we'll talk to you next time. Bye.
All right. Thanks, everyone. Bye bye.